All right, last talk for today. This is a shorter one. So hi, I'm Rasmus Bååth, and back in 2014, it was me and Ulrika that arranged the first Bayes Lund. And I guess we kind of did it because we really wanted to highlight the use of Bayesian methods at Lund University, but we also did it because we were pretty annoyed that null hypothesis significance testings and p-values were like so prevalent in teaching at Lund University. So this quick last talk, I want to go back to the roots of this mini conference and do some good, honest p-value bashing. All right, so p-values are bad. Yes, that's the premise. P-values are bad, and many people have written about. Now let's see here. Yeah, many people have written about the problems with p-values. There's thousands of articles. Some people have even written whole books about it, like Aubrey has. But one of my favorite articles is this short article by Haller and Krauss, which kind of highlights one problem with p-values, and that is that they are so hard to get right and so easy to misinterpret, even for people that should know better. All right, so it's misinterpretations of significance, problems students share with their teachers. Spoiler alert, yes, but we get to that. So what the Haller and Krauss did was that they had a survey that they distributed around their university, a questionnaire with the following premise. So let's suppose you did an experiment, one experimental group, one control group. You analyze this data using t-test and you got a p-value of 0.01. Which of these statements follow logically from this premise? So they gave this to students, to professors, and also to professors teaching methodology, right? Which of these follow logically from the premise? We've done a t-test, p-value of 0.01. Is it the case that you have absolutely disproven the null hypothesis? No, of course that's not the case. Is it the case that you have found the probability of the null hypothesis being true? Is it maybe 0.01? No, that's not the case. Have you absolutely proven your experimental hypothesis? For sure, you haven't done that. Can you deduce the probability of the experimental hypothesis being true? No. Let's see here. Do you know, if you decide to reject the null hypothesis, the probability that you're making the wrong decision? Are you considering the base rate when you're doing a t-test? No, you're not. So this is also false. But is it the case that you have a reliable experimental finding in the sense that if hypothetically the experiment was repeated a great number of times, you would obtain a significant result on 99% of occasions? This is actually also false. So all of these are false. And the question is now, how well did the psychology students, the regular scientists, and the professors teaching methodology, how well did they do? Well, the psychology students all failed. Like, they answered true on one of these statements where all of them should have been false. The regular researchers, they didn't do much better. And even the methodology instructors that should know better because they're probably teaching this, they also failed spectacularly. I mean, it's an open question to why. Personally, I think there's cognitive dissonance here. The distance between what researchers and students want p-values to be and what they actually are, that distance is so great that it's hard to kind of internalize what a p-value is. Now, but in this world, there's not only researchers and students, there are also amazing AIs. Since November, there's actually this amazing AI, it's truly amazing, called ChatGTP. So this is an AI language model, a chatbot, that's truly amazing. It's trained on a huge corpus, like Wikipedia is only like a couple of percent. It can correctly answer most questions you throw at it. And in many senses, it's a good alternative to Wikipedia. You can ask a question, it will answer. So if our confused student now goes to ChatGTP and asks questions about p-values, how well will that go? That is, how good is ChatGTP at knowing about p-values? So this is what I tried to figure out. And naturally, I started by giving ChatGTP the questionnaire from Haller and Krauss. So this is the full questionnaire. This is the kind of things that you can ask ChatGPT about. And initially, I was very impressed because for the first 4 statement, ChatGPT answered false. They are false. But then on the statement, if you decide to reject a null hypothesis, the probability that you're making the wrong decision, ChatGPT confidently answered true, and even gave the following rationalization that if you're using a significance level of 0.01, the probability of making a type 1 error or falsely rejecting the null hypothesis is 0.01. So here, ChatGPT also doesn't really know about the Bayes rate. And this is unfortunately the general pattern here. So the problem is that ChatGPT is trained on a huge corpus from the internet and knows a lot about p-values. It knows all the correct things that people have written about p-values, but it also knows all the false and weird and wrong things that people have written about p-values. And that's what you see when you ask ChatGPT about this. So if you just simply ask, unfortunately, ChatGPT fails this. So if you ask just simply what's the definition of p-value, ChatGPT is going to say a lot of right things. It's going to say that it's the probability of obtaining a test statistics as extreme or more extreme, etc. But it's also going to say nonsense like there is a less than 5% chance that the results are due to chance, which you can easily find people saying on the internet. All of this is probabilistic. So if you ask the same question, it's going to give you the different results every time. And it's also the case that if you change your prompt, your question a little bit, you can get better answers. I got a lot of luck with the following prompt here, where I say I'm a statistics professor, and repriming that, and then asking for how to define a p-value. I don't have time to read this, but actually I get very sensitive answers here. The problem is you don't really know what prompt is going to work. So if I just change this prompt a little bit, I'm not a professor, I'm a confused student. Suddenly it's going to start telling me nonsense again. Like a p-value is a probability that the result occurred by chance. So it's very hard. Also, ChatGPT is happily going to recommend p-values and t-test if I ask it how I can prove things. So here I'm asking, I done an experiment. How can I prove that the two groups differ? And it's happily going to tell me, yes, use a t-test and use a p-value. Like this is not logically possible to prove, but still use a t-test. So ChatGPT is an amazing language model. It has learned everything about p-values, all the right thing, and also all the nonsense. And I think the best example of this is the next one. So here I ask ChatGPT, I tell you, so here's a list of p-values that's from statistical tests and some corresponding verbal descriptions. So p less than 0.001, that's extremely significant. P less than 0.01, that's maybe highly significant. Please, ChatGPT continues this list for the following values of 0.05, 0.06, 0.07. So for 0.05, ChatGPT is doing the reasonable thing and just saying that, oh, let's call this significant. But surely ChatGPT, when it's 0.06, it's non-significant, right? Right? Oh, it's suggestive. And for 0.07, it's marginally significant. For sure, 0.01 is, okay, it's weakly significant. You have to go to 0.02 until it's actually non-significant. So it's even learned, this madness. Right. So can AI save us from the perils of p-values? I think right now the answer is no. And as long as this AI is going to be trained on data from the internet where people are wrong about p-values so much, I think it's going to continue being no. So what can be done? I don't know. I just know one thing. And so I took this survey of Halle and Cross and I just changed it a little bit to be about the Bayesian model instead. So instead of using a t-test, it was now using a simple Bayesian model, assuming the data is normally distributed with conformative priors. And we find that there's a 0.99 probability that the experimental groups performs substantially better than the control group. And then, so I just modified this to be about the Bayesian model. And when I did that, ChatGPT actually gave me the correct answers. It told me that there's strong evidence that there's a difference between the population means. And ChatGPT says true, based on the data and the Bayesian model, the probability of the experimental group performing substantially better than the control group is 0.99, suggesting strong evidence for difference between the population means and so on. So it did fairly well. So p-values, ChatGPT doesn't really know about p-values and humans don't. ChatGPT is pretty good at answering questions about Bayesian probabilities, and maybe humans as well. It's up to you what to make of that. And thank you so much for listening to my talk.